Hi, good morning. As you know, I'll no longer teach math as a live lesson online. So I planned that I'll make lessons videos such following. My lesson videos time will be about 25 minutes. And in the last 15 minutes of the lesson, you will write in your notebooks and uh, in this lesson. For this, I'll send you lesson notes that I thought with the lesson videos, and then I'll upload the lesson videos, Google Classroom, and I'll provide you to be accessible on lesson time. As you know, we state binomial, the normal approximation to the binomial distribution, and the last topic of the viewing the last year lessons. It's very important for us this topic. Today we will learn the normal approximation to the binomial distribution. Okay, we can start and find the probability of obtaining exactly 60 hats with 100 tosses of a fair coin. If you notice that we have two possibilities. Uh, our possibilities, one of both hat or the other one tails. So if we have two possibilities, this is binomial distribution. And if we want to uh, compute the exactly 60 hats, exactly 60 hats, we will compute in binomial distribution formulas combination 100 to 60 multiply 0.5 to 60 and 0.5 to 40. You know, uh, if we want to come hat, hat probability is 0.5, and uh, tails probability, or it means Q, 1 minus 0.5, so 0.5. And if we want to six, 60 times hats, so we will compute and use the binomial distribution. But if they want us, if we they want us obtaining 60 hats or more hats. If our question is 60 or more hats, and if we want to use binomial distribution, it's very long. It becomes very long formulas, a long process. For example, it will be 60 hats and 60 hats of probability, or 61 hats probability, because they want us 60 and or more hats, and 62 hats probability, and then 60 then 100 hats of probability. So it's very hard formula and very long process. Okay, now we will learn if we have such as these long situation, what we will do, and how we can use binomial approximation to binomial distribution. Okay, now, however, in certain situation, we can approximate a probability such as these by a method that involves far fewer calculations using the normal distribution. And the binomial distribution, if you remember, n means number of trials, X means number of success, P means probability of success, and Q means probability of failure. If in your binomial distribution situation n equals and or greater than 20 and multiply p greater than 5 and multiply q greater than 5, your binomial distribution approximation to normal distribution. So we will use, as you know, nu. Nu means the mean, and key means standard deviation. Nu equals to n multiply p, a square root of n multiply p multiply q. Okay, we will learn. We learned these formulas last weeks, so we will go on. And I want to show something the on the GeoGebra, how the binomial distribution approximation to normal distribution. Okay, now I want to share my screen and and okay, and I will show the normal distribution approximation to binomial distribution. Okay, now we have a binomial distribution. Yeah, and if you look at this graphic, if you look at this graphic, and you know trial, the number of trial, you know the probability of success. So I put the 0.5 probability of success, 0.5, and trial, the number of trial, and maybe 20, and you can see the graph, the binomial distribution graph, and the normal approximation to binomial distribution. And if we want to uh, draw the curve, this normal distribution means that's, you know, this is a perfect curve and symmetrical curve. And you know, if you have the binomial distribution p equals to 5 and trials, the number of trials greater or equal than 20, your the normal approximation to binomial distribution. But if our trial very little, if very so little, for example, five times, for example, 5 times, and it's the normal distribution breakdown. So and if you increase the trials number, and your curve, your curve approximation to normal distribution. Okay, now we learned uh, how should we uh, we have the uh, binomial distribution for approximation to normal distribution. And one more time, n equals to or greater than 20, and multiply p greater than 5, and n multiply q greater than 5. So the normal distribution, the normal distribution approximation to binomial distribution. Okay, now uh, for example, we have a question, and there is 80% chance that a student will pass a statistics course. A random sample of 30 students taking the statistics course is selected. Find the probability that at most 25 students will pass. And if you look at this question, you have two possibilities. One of both pass, and second of both fail. So this distribution is binomial distribution because we have two possibilities. The normal distribution can emulate the binomial distribution. For these, let's check those certain circumstances. So our real number is 30, and our real number is 30. It means greater or equals than 20, and success of probability 80%. So 80%, it means 0.8. And n multiply p, it means 0.8, 0.8 multiply 30 equals to 24 greater than 5. And n multiply q, it's necessary greater than 5. So q means failure, probability of failure. So 1 minus p, then 1 minus 0.8 equals to 0.2. So 30 multiply 0.2, it means 6 greater than 5. Okay, the binomial distribution and the illustrated to normal distribution or approximation to normal distribution. And so we will compute the nu and standard deviation. Nu means n multiply p, so n 30, and probability of success 0.8. It means 24, and square root of mpq, and this it means 4.8, and approximately 2.1908. It means we have 2.2. We can accept this value. And then uh, if we have this situation, and we have probability, probability uh, and x value, you know our question related to uh, at most 25 students. It means x x uh, x uh, less or equal than 25. And you know we learned this probability transformed z values. If we want to this probability z values, x uh, x means x transform z and less or equals than x, it means 25, minus nu, it means 24, over standard deviation, so 2.2. And our probability of z less or equals than 1 over 2.2. Approximately this means 0.45, and z less or equals than 0.45, 0.45, 45. And then we will use the z table, and we will find the 0.45. 0.45 it's here. 0. Firstly, we will find 0.4, and we will find 5, and 0.45 corresponding to both column. It means 0.67 and 36. 67 and 36. Okay, and it means 0.67 and 36. But in the binomial distribution, the normal distribution, the approximation to binomial distribution, if we figure out such as this situation, we will we have mistake, because we have correct continuity correction. So you know uh, 0.45, if I want to on the graph, if I want to on the graph, 0.45 are values, and then again, our trial, the number of trial, means 30, and probability 0.8. 30, 0.8. So n value 30, and probability 0.8, 0.8, and use that value, if you look at these binomial distribution and approximation to normal, and your z value, your z or x equals than 25, and 25, if you look at the carefully, 25 point is middle of this column, but you want to less or equals than 25. So if you want to this from 25 to negative infinitive, for example, this area, you have and you need you need continuity correction. So I computed the from this point and then this area, from this point and then this area, but if I compute these points, I will be correct. So we have another another process. The process name is continuity correction, and we should we should compute we should compute x equals and less and equals than 25, and if we use the normal distribution, we should use x less than 25.5, because again, I will tell about this situation, because 25 is here, and 25 the middle of this column, but you have to this all this column area, and you have to start this point. So this point is 25.5. It means, and it's called uh, continuity correction. So if we compute the probability of x less than 25.5, it's very truly, it's very approximation to true value. And we have to transform that value, that less than 25 minus nu over standard deviation, or 2.2, and probability z less than 1.5 and 20 over 22, and uh, we have approximately 0.7 that's less than 0.1, and we will use the z table, and the firstly we will use 0.7, and the second 0.1, and corresponding the these column 0.75 and 11, 75 and 11. So our value 0.75 and 11, and this value and this value very different, but as correction continuity correction, you make continuity correction, your value very closely the true value. So you have to continuity correction, and this value very long, very far to true value, but this value very closely, and you have the continuity correction. Okay, now we will more practice about continuity correction. Let x be a binomial random variable with n, it means trial, the number of trial 75, and probability of success 0.6, what's new, and what is variance, and p. Okay, now we have to the first time nu, or it means mean, and multiply p, so 0.6 multiply 75, and uh, 3 over 5 multiply 25, and it means 45. And 45 our new value. And standard deviation or variance, it means n multiply p multiply q, and n is 75, p is 0.6, and q 1 minus 0.6, and 75 multiply 0.6 and 0.4, and 75, 3 over 5 and 2 over 5, and it means 80. And your standard deviation is square root of 18, approximately 1.2 BR. Okay, now what is a probability of x greater or equal than 52? If you figure out by binomial distribution, you can come across to a very long process. So our exact value 0.0611. If you without continuity correction, and you want to figure out by using only the normal distribution, but the first time transform the z, so z equals and greater than 52, because you around to x greater than 52, and z equals to 52 minus nu and over standard deviation, and it means z greater and equals than 1.64, and this normal distribution value is 0.0495. So if you notice that exact value and without continuity correction, you only use normal distribution formula, your value and exact value are very different, and are very far from each other. Uh, so we have to exactly make continuity correction. But we can improve the approximation with a continuity correction. We are moving from discrete binomial distribution to discontinuous normal distribution. And when we do that, we can improve the approximation with this continuity correction. Please notice that you uh, you uh, you want to probability of x equals and greater than 52. So you have to figure out this area. You have to figure out this area. But 52 points, 52 points, exactly the middle of the this column. 52 points, exactly the middle of the this column. And if you figure out this probability value, you you will figure out this area. So you didn't figure out this part. So we need to continuity correction, and and if we add this green area, and we will find the value very closely the exactly value to exactly value. So we have to compute all these situation exactly. uh, we we will figure out this area, and and this point means 21, and this point is 21 and 21.5, because 21 the middle of the this point, this column, and this is 20, this is 51. This point is 51.5, and if you want to compute to this area, x x greater and less than 25 22, but you have to compute x greater than 51. This process name is continuity correction. Okay, now, and and we have to, if we have to if we have to these points, for example, uh, probability of x greater than 52.5, very closely exactly value. And if you want to uh, probability of x